Again, we want to check how the FPS settings works. So the processing FPS is currently set to 30. If we change it, is the calculation of the BPM still accurate or not? Yeah, we have an incorrect BPM calculation when changing the signal processing FPS. This is interesting. It's replacing the filter. Why are we replacing the filter? Based on your detailed analysis, the issue with the BPM calculation at different processing frame rates stems from the bandpass filter implementation. The existing filter doesn't correctly handle frequency scaling when the sample rate changes, leading to inaccurate peak frequency detection. I will replace the current Butterworth bandpass filter class with a robust second order Butterworth filter designed using a bilinear transform with a frequency pre-warping. Doesn't sound legit? This ensures the filter's characteristics remain accurate across different sampling rates, resolving the BPM calculation error. And it's proceeding with the changes. And what did the new Gemini 3 Pro is suggesting? It regenerated the code. Why? Regenerate the whole code. I have replaced the flawed Butterworth bandpass filter class with a new implementation uses a cascade of second order Butterworth high pass and low pass filters. That actually makes more sense to me. Yeah, these filters are calculated using a bilinear transform method using the math.10 pre-warping step. So is it the same? And we can test it. We should be able to replicate the problem first, don't we? Let's replicate the problem first. Yeah, so that's a correct measurement. Yeah, and that's an incorrect measurement. So supposedly, after it changes the code, let's go with Gemini Code Assist. So yeah, so the advantage of using the AI Studio, the model, you have access to a more recent model, but then the Gemini Code Assist has access to the code, so it's modifying the code directly. Well, whereas the Gemini 3 Pro just regenerated the whole thing. So let's try what Code Assist did. Has replaced the filter implementation as requested. The new filter uses the bilinear transform method to ensure accurate BPM calculation across different processing frame rates. Yeah, and then the next question would be what happens if we have a non-stable FPS, like on a lot of mobile devices, or some mobile, or at least my mobile device. So this will be the same thing, except that now, yeah, we have a good reading again. Yeah, that looks legit. And when we change it to 60, we should still have 70 BPM. Yes, that's inaccurate because, yeah, we should be getting this 70. So no, there's still something wrong. Yeah, I'm sure that's the correct value. Because we did a comparison to a smartwatch. But yeah, that didn't seem to work. I don't know why it's something else. Let's try the implementation from the new and amazing Gemini 3 Pro. Yes, we got the 70 was correct. Now we're getting more noise in it. Wait, what happens with, say, 15? Should be still getting the 70. This seemed to work. Yeah, so the new Gemini 3 potentially have solved the problem. So we're currently on 15 FPS. Yeah, it's actually pretty accurate now, even with 15 FPS. Now the question is, what happens if the FPS is variable? What happens if the FPS is variable? So let's just check another FPS value. Yeah, why is it elevated? So we have an amplification factor of 150. That's default. Let's leave it at default. I don't think that's the problem. Then we have processing FPS of 30, and that's working fine. We checked 15. Let's give a okay reading. I'm pretty sure it's 70. Compared to the smartwatch again. Hey, compared to the Garmin. Let's see what we get. The Garmin can also be sensitive if you put it to too tight or too loose, whatever. It will give you wrong readings as well. I actually stopped wearing it because it's giving me like irritation. Yeah, I still get the 70. Yeah, the thing is showing me 71, so that's fine. That's okay. But then what happens? Again, we're still testing the FPS. If we increase the FPS, whatever number there is, it should just still give an accurate BPM. So it should still be the 70. No, the 76 is wrong. Interestingly, if we go in 20 FPS, I think if you go lower, it might be still working, but when you go higher FPS, it gives an off rating. It's like multiples of 30. Maybe just multiples of 30 work. Yeah, I'm not sure it works. It's like hallucinating. We need to actually measure the actual FPS. Like the set FPS and the actual FPS can be different, can they? Okay, so the set FPS that we want can be different from the actual FPS the system is doing. Shall we display more information to the user? Can we actually display what the actual FPS is? Because the main reason we're doing this is that the calculations still seem to be correct. So it still seems to be only working when the FPS, the processing FPS setting is set to the default 30 frames per second. Let's give it to that Gemini 3 Pro. Should we also ground it with Google search? I don't know. Let's do it. Let's do grounding with Google search, see what we get. The mathematical filter, the Butterworth implementation, calculates its coefficient based on the target FPS. However, if your webcam or computer can only physically deliver 30, the actual FPS the filter receives data half as often. Mathematically, if a filter expects data at a certain FPS but receives half, the frequency response stretches. A heartbeat of 70, which is 1.16 Hertz, 70 BPM. That's what you should be seeing over there. Will be interpreted by the filter as if it much slower. The filter, the filter's bandpass effectively shifts filtering out the real signal. Shall we just get rid of the shall we also have a toggle for the filter? Okay, now we'll have actual number in the target slider until it matches the actual number. Adjust the target slider until it matches the actual number. When they match, the math and the reality are aligned and the BPM will be accurate. You know, it's the common problem. Okay, so it finished the code. Let's check it out. So the actual FPS is fluctuating quite a bit. Okay, this is why do you think the processing, if the processing FPS is set to 30, why the actual showing me 48, 58, so on and so forth? It keeps fluctuating and it's not just limited at 30. Why would that be the case? It's going actual up to 60. I don't know why. I don't think it's accurate. I don't think it's accurate in the code. The main loop function is driven by request animation frame. Browsers typically try to run this loop as fast as possible. The current code counts every time the loop runs, not every time the heart rate is calculated. The throttle inside the loop, there's an if statement, ignore extra frames. The mistake, the variable frames this second is currently sitting outside. Yep, there's some sort of problem. I'll have to regenerate the whole code. Someone is asking, how can you estimate BPM? We'll do a summary of the chat. So we're chatting to Gemini 3 Pro. We'll do a summary and we'll include this as a question. It should be explained in the bottom of the page as well. But currently it only works with 30 FPS. We are regenerating the whole code. Okay, now we have the processing FPS set to 30 and the actual is set to 30. Sometimes it's fluctuating to 29, but that seemed to be an okay error to have. We can deal with that probably. Now, okay, let's do the reading again. Should have our 71. Yeah, that's correct. Set it to 40. Should be able to do 40. I was doing 35. And the reading is off. It's to 20 and the actual is 20. So that's nice because we don't need more than 20. Probably don't need more than 15 or so. We can get away with like 6. But what's worrying is the reading is off. The reading is off. Any ideas how to fix it? Should we have a toggle for the filter as well? Need to explain the problem in a different way. We'll have to explain the problem in a different way. I don't know what's wrong, but it's good to have the actual FPS. Can to 60? No. And that's okay. We don't need it. There's something wrong when switching potentially as well. So it's not doing what we set it to be. Yeah, it's giving the 70 reading. If we set 25, actual is 25, so that should have no trouble matching it. But the reading is off. It should not be 76. It should be 71. Oh, but having trouble. We are having trouble. Okay, so this is working great. Keep everything as is, but we're having one problem. When changing the FPS from the default 30, the calculated beats per minute is not correct anymore. Shall we also try and have an option to turn the filters off to have another toggle for it? Okay, this is the correct approach. The issue with the BPM being incorrect at 60 FPS when your camera might only be doing 30 is that the FPS math calculates frequency based on targets. No, that's the actual rate. I have made 2 changes. That's actually not a problem, but never mind. Added the disabled bandpass filter toggle located. Yep. Fix the BPM maths. The graphs and BPM calculation now use smoothed actual FPS rather than the slider setting. This ensures that even if you set the slider to 60 but your computer only handles 30, the math adjusts automatically and the BPM remains accurate. It actually sounds really convincing. And I'm some sort of expert in this stuff, so it's able to convince me. But then the question, would be able to implement accurate code? I believe it would. It's using like the best model out there. Someone is asking me if I'm human or something. Yeah. Like if you have to ask that question, what difference does it make? Like you wouldn't know the difference anyway. So why does it matter? Okay, so it made changes to the code. Currently we have 855 lines. The new version has 775. Okay, that's a bit suspicious. That's a bit suspicious. What did you get rid of? Okay, let's test it again. Test it some more. To test, retest, test again. Okay, so doing 30. That's the default. Okay, still getting us 70, whatever. 69, 70. $36. $72. That's correct. Let's do 21 FPS. Should probably just limit it at 20 or so. No, so that's incorrect. The reading is incorrect. Any ideas? Anyone? Mueller? Okay, I'm lost. I don't know what to do. Wait, we should have had the filter. Disable bandpass filter. No. Okay, obviously that stopped working as expected. That's not good, is it? Disable bandpass. Can show the raw signal. Are they two filters? We should be disabling them separately, the high pass and the low pass. But yeah, we're still having the same problem with the FPS calculations. Something wrong that the FPS is not being taken into account. Okay, first of all, for the disabling the filters, can we have separate toggle buttons for the low pass and the high pass? And we would actually like to keep the high pass on by default and the low pass off by default. And the main issue, the reason we keep doing this, the reason we keep making changes is because the BPM calculation is still wrong. So it doesn't seem to take into account the actual frames per second value. It seemed to only work with the original value of 30. So there's something hard-coded somewhere in the code. Okay, filter toggle. We'll have separate one for high pass drift removal on by default, low pass noise removal off by default, as per my request. Thank you very much. And hard-coded BPM fix. You're right. The issue was that while we were measuring the actual FPS, the bandpass filter itself was still configured using the slider value. Okay, just fix it. Let's see. Yeah, models. Originally, the idea was, by the way, to find the skin, the whole skin, instead of just doing the ROI. And then we have a manual ROI. We can select the box on your skin. We have an automated ROI that will find your forehead for you. So that's working okay-ish. Except I'm not sure what's happening when when the hairline or something is in it. So that's still yet to be tested. Okay, we have the updated code 775.782. Okay, so it's longer. No, this longer means better. Probably not. Okay, we enable high pass, enable low pass. Okay. Can do the actual, can get a quality reading with that. Yeah, we're getting our promised 70. Just enable high pass as well. And do another one. Try changing the FPS. It's actually sensitive to the light. Wait. Actually, natural light might be better for it. Do we need more amplifications? Because we can go all the way down to 10, can we? No, it definitely need the high pass to get rid of the baseline drift. 76. Mine shows 74. So that's okay, I think. Okay, we definitely don't need to go all the way up to 60. Default can be like 20 or something. Default is 10 to 30 and default is 20. Can we just change the processing FPS slider values What do you think good values be? And what do you think about the minimum of 10, maximum of 30, and default value of 20? Obviously, we can change it manually. Yes, I know. We can do some manual editing to the code, but that's a concept that we are interested in, not the actual. Yeah, and we don't want to hard code anything. Ideally, we want to have any magic numbers there at all. Well, that's why we're choosing a range. We'll have to preset something, but yeah, so we're going 10 to 30 with a default of 20. Hardware real, 99% of standard webcams run approximately of 30 FPS. Yeah, so 60 doesn't make any sense. So yes, we would make 30 the maximum. Nyquist theorem to detect heart rate, which is roughly between 1 and 3 Hz, you mathematically only need the sampling range of about 6 Hz. Setting the maximum to 10 is safe and provides enough overhead. The default of 20 is a sweet spot that provides a smooth visual graph, but uses 33% less CPU power than running at 30 FPS. Here's the updated code. Yeah, everything we do eventually is available on BioniChaos.com. Okay, it's now hallucinating on me, or... Okay, so it's saying this is a classic signal processing problem known as sampling jitter or frame quantization error. The explanation why 20 FPS fails when the camera is 30 FPS. Your webcam captures light at a rigid physical interval, usually every 33.3 milliseconds, 30 FPS. At 30 FPS setting, the slider asks for frame every. Camera provides, yep, they are synchronized. You get a smooth periodic stream of data. At 20 FPS, the slider asks for frame every 50 milliseconds. Okay. So time 0, we grab frame 1. Time 33, camera captures frame 2. We ignore it, waiting for 50 milliseconds. Okay, it makes sense. We want to, at 50 milliseconds, we want to sample the freshest image, which is now 17 milliseconds old. We process it. Camera captures frame 3. We want to sample ideally. To fix this, we cannot rely on average FPS over 1 second. We must calculate the time difference every single frame. Would it be just easier to remove to prevent the user from changing the FPS setting manually and just use the actual FPS and keep the indicator of what the actual FPS is? So essentially removing the processing FPS slider, would that fix all the problems? Yeah, I might get rid of it. Well, because the next question is what happens on devices where the FPS is actually variable. So the camera is doing 30, but 30 is an overkill. So we can do like multiples. So no, we should keep that setting, but it should be just multiples of 30. So it could be a 30, could be 15. Was it 7.5? Removing the slider is the best engineering decision. By forcing the system to run at its actual FPS, which is dictated by a browser and webcam hardware anyway, we eliminate the conflict between what we want and what the hardware is doing. Yes, we remove the processing FPS slider, added a simple current FPS monitor. The system now processes frames exactly as fast as your browser allows, regardless of whatever your computer runs on 30, 60 or 120. Okay, I'm still generating the code. Everything we do is deployed on BioniChaos.com. Okay, we're having a calculation issue. Okay, so we're not getting a stable FPS, which might be a problem. I think that's what causing the calculation to be off. Everything we do is available on BioniChaos.com. Check it out, provide your feedback. They calculate BPM frequency. Calculated math assumes that time between every single data point is identical. If your webcam delivers one frame at 30 and the next one at 40, yeah, the jitter frequency spectrum gets smeared, causing the BPM to jump around. The solution, signal resampling interpolation. Yeah, because it's fluctuating quite a bit from 48 to 51 and so on and so forth. Resampling, the linear interpolation, stable maps. Yeah, we're turning both low pass, high pass on by default. The time step logic implemented resampling loop. The signal processing now runs strictly at 30 Hz. Mathematical time. Completely decoupled from the visual frame rate. I don't know how well it will work on other devices, but okay. Okay, it broke something. Hey, can we fix it with an agent? Let's get the Gemini 3 Pro the same prompt. Let's see which one does it quicker in this case. I'm sure both of them can do it. Okay, so we have 60 watt webcam input rate. Why does it say 60? Is it accurate at all? Can see a good waveform. Yeah, we get a 70. Yeah, so that seemed correct. Now the problem is, what was the problem? Why does it show now webcam input rate of 60 FPS? It's not 60, is it? But it's hardwired to 30. So yeah, not sure what's going on. Yeah, so hopefully it will work okay on other devices as well. We can deploy and test it. Anyhow, now that we have the webcam input is actually fluctuating, it still should be working okay. The filters work, so we can have the unfiltered, enable low pass. Yeah, you can just show the raw signal and that shows you what the filter is doing. So it's kind of nice. Yeah, mainly removing that baseline drift, DC drift, whatever it's called. Yeah, kind of locking in on 70. My thing's showing, yeah, 70 as well, close enough. So hopefully now, so we essentially got rid of the FPS setting slider. So hopefully it should be more stable on other devices. Yeah, and we added more filtering options. Enable high pass, so they're both enabled by default. And the low pass, you can turn them off, see what happens. Or show the raw signal, which is actually disabled by default. So default, yeah, you can see the actual calculated, not the actual input frames per second rate. So that will depend on your camera and your system, whatever. If you're on the phone, it will show you something different. But then the calculation is made assuming 30 Hertz. But what if you have a camera that does 60 Hertz? I don't know. Okay, so now the web application is assuming the camera is working at 30 frames per second. Is that correct? Hey, can we explain in the text below the web application at the bottom of the page what happens if we have a different camera that doesn't do 30 FPS, that does something else? Yeah, so we're doing all the live, all the development is live on YouTube, and then we deploy everything we do onto our website, which is called BioniChaos.com, which you can see on my screen right now. So you can go and play with everything we developed in the past, including webcam filters and this one, which is measuring your heart rate from the web camera. So it was working on my machine properly, but people were complaining. I think it's not working if your frames per second is not stable or not stable enough. But now hopefully we fixed it. Maybe. See. Have to test it. But if you check the website and you have any specific questions, I'm more than happy to take them on. Probably they will be turned into prompts for future development. So okay, let's see. If your camera is 60 FPS, the system takes the extra data and averages it down to perfect 30 Hertz timing. Okay, This is actually results in cleaner signal. So it's kind of assuming that the 30 FPS is the minimum you've got. If your camera is 15 FPS, the system uses math interpolation to fill in the gaps between frames to maintain the 30 Hz timing required for the filters to work. Okay, here is complete code. I have restored the full detailed text explanation, expanded on science, added specific segment. Yeah, we already had it before. Hardware capabilities. What if my camera isn't 30 FPS to once? Yeah, so it will have a Q&A on the page itself. After the live development sessions, whatever we do is being deployed on BioniChaos.com, so you can go check it out and play with the tools yourself. The source code for the more recent applications is just on the page, so just go F12. It's all JavaScript, so it should be all front end. We used to do back end stuff, but try not to do it anymore. Anyhow, complicated. Don't worry about it. But yeah. Alright, so we added all the explanation for what happens if your camera isn't 30 FPS, and it should have all the science and so on and so forth, links and things on the page as well, so, which we had before. Just one of the prompt responses just decided to get rid of it. Yes, we're getting a nice waveform. It's locking in on 70 something. Ooh. Is my watch accurate? Oh, I really got going with the previous monologue. My heart rate got elevated by 10 beats per minute. It's like 80 now. But wait, and the measurement is showing. What's the measurement showing? Because we're still testing it. Now it should not be affected by the frames per second. 77. No, it's locking in on 70. Am I back to 70? Yes, I am back to 70. Okay, we solved that problem. Okay, we have the explanation. Okay, hardware capability about this application. Yeah, it's remote photoplethysmography. Don't try pronouncing it at home. Your tongue will get twisted and fall out eventually. Okay, if your camera is faster, if your camera is slower, how it works, ROI selection, disclaimer, yeah, demonstration, and education, not medical device, yep. Future direction, multi-person. What? Why would you do multi-person? Why would you do multi-person? Like in a crowd situation. Motion compensation. Okay. Deep learning, yeah, of course. Infrared cameras, okay. Yeah, if anyone wants to send me an infrared camera, I could do something useful with it for sure. But I don't have one handy. Thermal cameras, any sensors, any medical sensors. Send them all. Anyhow, we might finish at this. We actually fix it. We'll be testing. We'll deploy it. You'll be able to find it on the site. Should be links everywhere. We can deploy. As I said, don't forget to smash that like and subscribe button, because then you won't miss future live streams. So when we are live, you should be getting a notification, and you can join in, ask questions, obviously, after you visited BioniChaos.com. Holding it doesn't help. You actually have to somehow make sure it's stationary. That helps as well. Yeah, I get the 70. Okay, so we made an FPS, and now it should work better on any device, regardless of your actual fluctuating frames per second. It should still give you an accurate beats per minute reading. So go check it out. Let me know if you have any questions. Don't forget to smash that like, subscribe. I'll see you next time. Bye.